Okay, so let's go through this. We are moving on to the stuff from chapter 13. We're just going to hit this quick because we got to talk about this ANOVA thing, which ANOVA stands for Analysis of Variable. It's an abbreviation that they use. So, but that's what we're going to be talking about, the F distribution and the one-way ANOVA. So section 13.1, we're just going to get some information about this, the one-way ANOVA. First of all, analysis of variance is an inferential method used to test the equality of 3 or more population means. So far, we've only dealt with 2 things at a time. Now we're dealing with, 3 or 4 or 5 different groups that we're saying, okay, are these means all the same? Okay. So in ANOVA, the null hypothesis is always that the means of the different populations are equal. So the null hypothesis is that they're all the same. The alternative hypothesis is always that at least one population mean is different from the others. Okay. Requirements. There must be n simple random samples, 1 from each of k populations. So you might be talking about, let's say that your different populations are adult males, adult females, and then adolescent males, adolescent females. That gives you 4 different populations to look at, right? And then you would take a random sampling from those populations, and then you'd compare something about them, okay? Or a randomized experiment with k different treatments. So you either have k different populations or k different treatments, and we'll see some examples like that. The k samples are independent of each other. That is, the subjects in one group can't be related, not like related, but related as far as dependent, independent, dependent. It doesn't mean like they're not related like a family. It means they're not related to each other in any way to the subjects in the second group. The populations have to be normally distributed. The populations must have the same variance. And we're going to talk about, there's a rule that we use to figure out. It doesn't mean that they're exactly equal, but they have to be pretty close to each other. Okay. That is each treatment group has population variance that's basically the same. The factor is a categorical variable, which, remember, it means it's a category. It's a label. It's not a number like you're measuring something. But then the response is a numerical variable. Okay, that's going to be how many or how much. All right, that was the end of 3.1. See, just some information. 3.2 is pretty much the same. Get us some more information. The F distribution, which is also called Snecker's F distribution or Fisher-Snekker distribution, is a continuous statistical distribution which arises in testing of whether 2 observed samples have the same variance. So that's just explaining it's going to be using this F distribution. If we did all the little calculations on this, we would be using the F distribution more. We're not going to do that. We're going to use the calculators and let it do the work for us. So we call the variability among the sample means between sample variability. In other words, one mean of one sample compared to the mean of the next sample compared to the mean of the next sample. So between the samples. And the variability within each sample, within sample variability. Okay, so that's if you take one sample and you find the variation in that sample. Okay, if the between sample variability is large relative to the within sample variability, we have evidence to suggest the samples come from populations with different means. And that's our whole question is, are the means all the same or are they different? So here is the formula that you're going to be happy that we don't have to worry about. Well, this is not the formula yet, but when we look at this, we're comparing the between sample variation to the within sample variability. Okay, and then they just start abbreviating the mean square due to treatment, mean square due to error. And so anyway, we're not going to have to do it. We're going to use the calculators. So that's 13.2 to get us again further down the road. Now we're ready. We're going to start doing something now. Oh no. So, well, not quite yet. Some facts about the distribution. First of all, the curve is not symmetrical, but is skewed to the right. We're going to find out it actually looks a lot like the chi-square distribution where it's skewed to the right. Okay. There's a different curve for each set of degrees of freedom, same as chi-squared, right? The F statistic is greater than or equal to 0, just like chi-squared was. As the degrees of freedom for the numerator and for the denominator get larger, the curve becomes approximately normal, just like chi-squared did. Remember, the higher the degrees of freedom, the more it was like a normal curve. So a lot of these things are similar to the chi-squared that we just finished up. And some other uses then of the F distribution includes comparing two variances, and the two-way analysis of variance. We're not going to be doing that. We're just doing one way. Okay. So we've got one big requirement that we've got to look at when we deal with these, and it's the one-way ANOVA procedures may be used if the largest sample standard deviation is no more than twice the smallest sample standard deviation. So whatever the biggest one is, it can't be more than twice what the smallest one is. Because remember, we're dealing with more than two groups. So we just pick the biggest one and the smallest one, and we're going to compare the two. And I'm going to show you how to do that as easily as possible. So here's our steps. And again, you're going to want to use this on your homework. The steps on the A4, which is what you guys are using on your phone, or the calculators you guys have here are 84s also. First of all, we enter the raw data. Each sample goes in the first sample in list 1, second sample in list 2, third sample in list 3, and so on. However many sample groups, how many different populations you're dealing with. Press stat. Again, highlight tests, and then we go all the way. I think it's the very last one on the bottom is going to say this. And we'll do this together in a few minutes, but that's what we're looking at. Enter the list names into the ANOVA function. So what's going to happen is it's going to bring this up with a parentheses, but there will be nothing after it. So then what we'll put in is L1, comma, L2, comma, L3, comma, however many of them we have. Okay? And then once we're done, we'll close the parentheses and hit enter. And then it'll tell us what we need to know. Okay? So we're going to practice this a little bit. As part of an experiment to see the way different types of soil cover could affect slicing tomato production, Marist College students grew tomato plants under different soil cover conditions. Groups of 3 plants each had one of the following treatments: either bare soil, a commercial ground cover, black plastic straw, or compost. Oh, groups of 3 plants. Okay, yeah. So all the plants grew under the same conditions and were the same variety. Students recorded the weight in grams for the tomatoes and produced by each of the 15 plants. So there were 15 plants total. And again, this is the sample for the bare ones, because they had 3 that were bare, 3 that ground cover, 3 for plastic, 3 for straw, 3 for compost. So they're giving us the information. And the first thing that we have to do is verify the requirements in order to perform the one-way ANOVA are satisfied. And that one requirement that we're going to look at is the standard deviation of the largest one no more than twice the standard deviation of the smallest one. Okay, so I'm going to show us how to do that. I'm going to show you guys how to do that. So grab your calculators or your phones, and we're going to get to it. So we're going to go to enter our data. So we're going to push stat, and whoops, I'm in the wrong screen here. Stat and edit. So we're just going to put in these numbers for L1. This is going to be L1, L2, L3, L4, and L5. So we're just going to enter in those values, and you can go ahead and do that. You don't need to wait for me, but if you don't have, let's see, if you've got one of my calculators, you may not have enough rows because sometimes they get deleted. So, or enough lists. If you need one added, just let me know and we'll get it added. 2625. Okay, so everybody got their 15 values typed in here. Okay, so the first thing we have to check is to find the standard deviation of each one. So we're going to second mode to get out of that screen after we've entered it in. And then here's what we're going to do. We're going to go back to stat, and we're going to go over to calculate. And what we want to choose is number one variable statistics, because it's going to tell us the sample standard deviation. So when we do that, notice it'll say which list we want. Are you guys all saying that? So for the first one, we just want to pick list 1, and we're going to hit enter until it gets down to calculate, and then we hit enter. And so what we need to look at is the SX. Remember, SX is the sample standard deviation. And SX for this one, it looks like it's 1,228.9. We'll go with that. Does that make sense? Everybody see that? Are you getting the same answers as me? Okay. A few people are nodding. Some people are looking at me, and so I wasn't sure. Okay.
Well, mine didn't ask me for L1, but it just gave me that.
Okay. So yours, you may, okay. So you should be fine on L1 because it'll automatically do L1. When we go to L2, we might have to put something in. So give me just a second, and I think we'll be able to get that taken care of. So then we're going to do the same thing. Second stat, or not second stat, just stat. Sorry. And okay, start over. Stat, calculate, one variable statistics, but now we want to go to the second list. So we're going to type in L2. The way we type in L2 is second 2, and it'll change it to L2.
It's go directed.
What's that?
It's go directed.
Calculate.
Second.
Number one. Yeah.
It's just the mention.
You got directed.
I think you were up on something else. So then we want to go to there and change that to L2. So okay, and then second 2. And then you should be able to hit enter. So when we go down to calculate, this time we're going to get 168.08. Are you guys getting that? 168.08? Well, we can basically stop now because what do we see about this one compared to this one? Is it more than twice as much? Isn't 1228 more than twice as much as 168? Right? So our requirement isn't satisfied. Okay. Now on yours, did you get that to come up? Did you just type in L2 after it?
Yes.
Okay, that's what I thought you'd have to do. But let's go ahead and finish this up. And I'm going to show you, I do want to finish the test so we see how it works. We've got another one too, but I just want to make sure we get a couple of times going through this because we've got all the data entered in already, so we might as well keep going. So the way we do the test, I think our next screen actually is going to say to go ahead and do the test. Yeah, now test the claim. So anyway, we found out we actually couldn't use it because we don't have the right requirements. But to finish this, to test the claim, here's what we're going to do. We're going to go to stat, and then over to test. And then actually, if you push up once, I think it takes you to that one. Instead of going down all the way, you can actually just push up and it'll go to letter A, which is the ANOVA. Okay. Is everybody finding that? ANOVA? Okay. Then we're going to hit enter. And remember, we had lists 1 through 5, right? So we're going to go second 1. And then comma. Comma is right above the 7, right up here. Okay, there's our comma. And then we're going to go second 2. So second 2 for L2, and then comma. And then second 3 for L3, and then comma. Second 4 for L4, and you guessed it, second 5 for L5. Above the 7, right up here. Okay, and then after the L5, I would just close the parentheses. The parentheses is right here above the 9. And then hit enter. And it'll probably have to think for a while. And notice the first thing it gives you is the F variable, 4.48. Okay, and that's going to give you P which is 0.02. So if P is 0.0, and then it gives you some other things, degrees of freedom and stuff like that. Notice the degrees of freedom is still one less than the number of groups we have. But notice the P is 0.02. We were not given an alpha, so what's the automatic alpha that we use kind of by default? Anybody remember? 0.05. So if our P value is less than 0.05, what would our conclusion be? Are these means all the same probably, or are they not? They're not. Remember, if P is less than alpha, we reject that null hypothesis, and the null hypothesis was that the means of those groups were all the same. So according to our test, the means of the groups are not all the same. Okay, does that make sense? Okay. So let's take a look at this one, and this one is talking about pennies, and this one is listed a little bit differently. So this time, the labels are over here. These are the pennies made in 1990. That's going to be L1 for us. 95 will be L2, and then in the year 2000 will be L3. So we're going to go ahead, and we're going to go back to Stat and Edit, and I'm going to clear off my other ones. You actually don't have to clear them off because we have enough values here that they'll just get typed over. But I'm going to clear them just to be that way. So notice we are going to start with the 2.5 and go across here for our first group, L1. And then we'll go across for the second group. I had to put it this way so it fit better. And I think, do we have 11? I got 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Good. Okay.
That's 11.
It'll be 11. We'll have 11 numbers there.
Oh.
And then we'll go to L2, and we should have 11 more. Okay, got those 11. This part of the video is going to be really boring. You're going to sit there. So then the question says, verify that the requirements in order to perform the one-way ANOVA are satisfied. And at the alpha equals 0.01 levels of significance, test the claim that at least one of the mean weights is different. Okay, so remember the first thing you have to do is compare the standard deviations. So we're going to go back, we're just going to do second mode, quit. And we're going to go to stat and over to calculate and then choose number 1. And we're going to use list number 1 initially. And we're going to get, looks like S is 0.022. And there's a 0 after it. I'll just do 4 decimal places just so that we have enough decimal places to work with. So then we're going to do the same thing. We're going to do stat, calculate, first one, and we're going to do L2 now. And that gives us 0.0243. We round it off. And then we're going to do the same thing. Stat, calculate, and we're going to do L3 this time. And this time we get 0.0151. Okay, so are we okay to use the test or not? Did you get a different number than me?
Mm-hmm.
Did I type it in wrong? Did everybody get a different number than me on that last one?
What did you get?
I got 0.0151. Okay, let me double check my numbers. Maybe I typed something in wrong. 2.5, 2.48, 2.49, 2.5, 2.48, 2.52, 2.52, 2.49, 2.51, 2.5. No, they're right. They're right.
I got 0.39. I got the same.
You got the same as me? So maybe double check your numbers. Maybe you typed one in wrong, because it's really easy when you're typing that many numbers to get one wrong. But this time I got lucky. I didn't get one wrong. And the first two were okay?
Yeah.
Okay. So we just got to double check our numbers. And we'll want to double check, because if we don't double check those numbers right away, then when we try to do the test, it may come up funny because we have different numbers. You got it?
Yeah.
Did you get it to come out or not yet, Sally? You're still double checking. Sorry. It shouldn't matter. Just go to the end.
And then
Yeah, it shouldn't matter, because it's just a list of numbers. The order doesn't matter. Okay, so once we have that and we've checked it, and this time we were okay, right, with our test. So we're gonna do what?
why are we okay with the test? Sorry.
Because these, if we take the biggest one,
Uh-huh.
it has to be, it can't be more than twice as much as the smallest one. So this one times 2 would be 0.30 something. So that's bigger than that.
It cannot be.
So this biggest one can't be more than twice as much as the smallest one. Like in that other one, we had a 168, and then we had like thousands. And so that's why we technically couldn't, that didn't fit the requirements. But I just wanted to practice doing the test, so we still did it anyway.
Oh, okay.
Okay. So once we've got that, what are we going to do to actually do our test? We're going to go to stat and over to tests, right? And then if we go up one, that gets us to the ANOVA. So we hit enter. And what do we have to put in after the parentheses?
L1,
L1, L2, and L3. So second 1, comma, second 2, comma, second 3, parentheses. And notice what we get this time. We are getting a F value of 1.053, which doesn't matter to us right now because we're not dealing with that. Our P value is 0.36. Okay. And alpha is 0.01. So what's our conclusion if we have a P value of 0.36 and alpha is 0.01?
We do not be-
So we're going to fail to reject the null hypothesis, which says they're all the same, right? So then test the claim that at least one of the weights is different. What would our response to that be? There is not enough evidence to state that one of them is different, right? Because our p-value is bigger than alpha. So we are not rejecting the null hypothesis, which means there's not enough evidence to claim the opposite of that null hypothesis. Okay, does that make sense? So I don't think this is too terribly bad. And I think that's it. Yeah, it is it.
Our problems up.
The problems are there. I don't think I've got a separate, just to talk about the test quickly, I don't think I've got a separate review on my open math for the semester final. And the reason is the questions that I put on the final are going to come directly from your tests. So if I was you, I would just work through my tests and make sure I know how to do all those problems from the old test. Now I realize that's a lot of stuff. I'm not going to test everything on all those tests. What I'll probably do is between 3 and 5 questions from each test.
3 and 5.
Somewhere between 3 and 5 questions from each test. Because some of the questions are going to be.
So 60 problems.
No, from each. We only had 5 tests. Not from each chapter, from each test. Sure. Let's say, in fact, 10 problems from each chapter, 120 questions, guys. No. So from 3 to 5, so maximum of 25 questions. I would say. I mean, some of them, it is possible I put a little bit more, like if some of them are like, is this I don't know if you remember back, is this a categorical or a numerical data? If you remember that, categories are like labels, numerical is numbers. Well, you're going to have to review it. Go back and review your tests. Because that was like, so anyway, so go back and review your tests, go through that. That's how you're going to, that's how I would suggest preparing for that final. If you want to stick around, I will try and get these graded as fast as I can so that you can have them back and you can have this chapter also, unless you're not worried about this one and you're more worried about the others. And then if you haven't already, fill out that course evaluation form and then screenshot it to me and I'll get you some bonus points for that.